What's up guys, this is Massey. Welcome to another video. In this video I want to talk about solubility and KSP values. So the first question, I have 4 questions in this video. The first one is calculate the solubility of solid Ca3PO42 KSP 1.3 times 10 to the power of negative 32 in a 0.2 molar of Na3PO4. So the first one is Ca3PO4 calcium phosphate, and this one is sodium phosphate. So the solid is calcium phosphate, so Ca3PO42 in solid form. When it dissolves, it's gonna produce the ions. So we're gonna have 2 phosphate and 3 calcium, both in aqueous phase. And then we have the ice table. Since this one is solid, we don't write it for initial and equilibrium. So initially, do we have calcium? No, we don't have before dissolving. But what about phosphate? Yes, we have. Why? Because we have Na3PO4 solution, 0.2 molar Na3PO4 solution. It means that the concentration of phosphate was 0.2 initially, 0.2 molar. Then change is going to be negative x, negative because it's consuming. And here we have 3x. Here we have 2x because the coefficient here is 3, coefficient here is 2. Now 0 plus 3x, 3x. 0.2 plus 2x. So we're gonna say KSP equals to 1.3 times 10 to the power of negative 32 equals to calcium concentration to the power of 3 times phosphate concentration to the power of 2. The concentration of calcium is 3x to the power of 3. Concentration of phosphate is 0.2 plus 2x to the power of 2. That's going to be equal to 1.3 times 10 to the power of negative 32. So now, because the KSP is a very small number, we can say that 0.2 must be much greater than 2x. So 0.2 is much greater than 2x. So we can say 0.2 plus 2x is going to be approximately equals to 0.2. So 1.3 times 10 to the power of negative 32 equals to 3x to the power of 3 times 0.2 to the power of 2, which is going to be 3 cubed, 27x cubed. 0.2 squared is 0.04. So 0.04 times 27, that's 1.08 x cubed. So x cubed is 1.3 times 10 to the power of negative 32 divided by 1.08. It's going to be 1.2 times 10 to the power of negative 32. So x will be cube root of this number, 1.2 times 10 to the power of negative 32. That's going to be equal to, the value will be 2.3 times 10 to the power of negative 11 mole per liter. So that's going to be the solubility. That's the value of X. Solubility of calcium phosphate. So let's take a look to the next example. As you see here, this number is much smaller than 0.2, so our assumption was valid. Let's get to another example. Here we have calculate the solubility of solid Pb3PO42 KSP 1 times 10 to the power of negative 54 in a 0.1 molar of PbNO3 solution. So we're gonna do it very similar to the previous example. What I'm gonna do, I'm gonna have lead phosphate in solid form. It dissolves and produce 3Pb2 plus 2 phosphate aqueous. So initial change equilibrium. We don't have it for solid form for initial and equilibrium. Initially, do we have phosphate? Yes, because we are finding the solubility in this solution, Pb and nitrate. So let we have 0.1, and initially there is no phosphate. So here negative x, 3x, 2x, that's it. It's done. 0.1 plus 3x, and here is going to be 2x. So KSP equals to, it's given. If it's not given, you can find it using the solubility product table. 1 times 10 to the power of negative 54 equals to Pb 2 plus to the power of 3. Why? Because the coefficient is P. Times phosphate to the power of 2. So 1 times 10 to the power of negative 54. The concentration of lead is 0.1 plus 3x to the power of 3 times 2x to the power of 2. Again, as you see here, you can say 0.1 because the KSP is much smaller than that, a very small number. 0.1 is much smaller than 3x, so 0.1 plus 3x is going to be approximately 0.1. So 1 times 10 to the power of negative 54 equals to 0.1 to the power of 3 times 2x to the power of 2. X squared, so it's going to be 0.004 x squared, 1 times 10 to the power of negative 54. So x squared equal times 1 times 10 to the power of negative 54 over 0.004. So that's going to be, equal to 2.5 times 10 to the power of negative 52. So x will be square root of 2.5 times 10 to the power of negative 52, which will be 2 times 10 to the power of negative 26 mole per liter. So this is going to be the solubility of lead phosphate in 0.1 molar solution of lead nitrate. Let's see another example. Now this example is saying that we need to find the solubility of cerium iodate CeIO33 in a 0.2 molar of KiO3. Solution is 4.4 times 10 to the power of negative 8 mole per liter. Calculate KSP for cerium iodate. So that's a little bit opposite. So we're gonna have this solid CeIO3 when it dissolves, it's gonna produce cerium 3 plus 3 iodate, both in aqueous phase. We have I, C, and E. There is no initial and equilibrium. And it says the solubility in a 0.2 molar of potassium iodate. It means that initially we have no cerium, but we have 0.2 in here. Then negative x plus 3x. In equilibrium is going to be x, and here 0.2 plus 3x. So KSP will be the concentration of Ce3 plus times iodate to the power of 3. Cerium is going to be x to the power of 1, and iodate is 0.2 plus 3x to the power of 3. Now the solubility is given, which is the value of x. That's 4.4 times 10 to the power of negative 8. So we just sub it there. So KSP equals to 4.4 times 10 to the power of negative 8. 0.2 plus 4.4 times 10 to the power of negative 8 times 3 to the power of 3. So that's going to be 4.4 times 10 to the power of negative 8, 0.2 to the power of 3. 3.52 times 10 to the power of negative 10 is going to be the value of KSP for this solid. Next example is finding the solubility of PbIO3 in a 0.1 molar of potassium iodide solution is 2.6 times 10 to the power of negative 11 mole per liter. Calculate KSP for PbIO3 2. So that's going to be lead iodate. It's going to dissolve and produce Pb2 plus 2 iodate. Initial change equilibrium. The solubility in 0.1 molar of potassium iodate. So there is no Pb initially, but here this one is 0.1. Negative x plus 2x. So we have x 0.1 plus 2x. So KSP will be equal to Pb2 plus times iodate to the power of 2. So that's going to be x times 0.1 plus 2x to the power of 2. The solubility, which is x, is 2.6 times 10 to the power of negative 11. .6 times 10 to the power of negative 11 times 0.01. That's going to be 2.6 times 10 to the power of negative 13. That's going to be the KSP value of this solid in this solution. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.